Alright guys, that should say Unit 3. Sorry about that. Unit 3, Systems of Equations. Number 1, which system of equations is accurately represented on the graph? So let's look at our equations here. I'm going to first look at the lines over here. So you have to be careful. They're both here, -1, 2, 3. This one's at -6. So I see the y-intercept of this line is at -6. So I'm going to first come over here and say, well, there's no -6 here. There's no -6 here. So I'm looking at one of these two. Okay? So then, let's see what we've got. Let's try to find the slope here. It's kind of hard to see. I'm going to go from here to here. Now this is -6, this is 6, which means this is 4 and 2. So this is actually down 2, 4, 6, and then over 2. So down 6 over 2, which would be -3. So -3x minus 6 is one equation. So here's -3x minus 6. This one's -3x plus 6, so I can't have that one, so it has to be G. Okay, number 2, tell me 3 things about each type of system. So let's just talk about what each one is. Here I have parallel lines. So this is an inconsistent system, which would be no solution. I'm fine with that, just classifying it and how many solutions. This one is independent, consistent. So think about this. They're their own line. They're each their own individual thing. That's independent. Think if like you are an independent person, or, you know, I don't know, something that makes you remember independent means they're their own thing. This one just has one solution. That solution is where they cross at. Then we have these two where they're the same line. These are dependent, consistent. And this one has infinite solutions. Because this one touches one time, but these touch every single point they're going to touch. Okay, so number 3, classify each system and determine the number of solutions. So a couple things here. Some of you guys are going ahead and solving these. That's fine, because if you solve them, you're going to get no solution. You're going to get one solution or infinite solutions. You don't have to do that, though. You could just get y by itself. So I'm going to get y by itself on this one, subtract the 8x over, and divide by 12. So I get, divide by -12. So I would get 2/3 x minus 4. Okay, then I look at this one. I need to divide by 3. I get 2/3 x minus 4/3. Okay, the slopes are the same, but they have different y-intercepts. So that would be this one. Slopes are the same, different y-intercepts. So to classify, I would say inconsistent. And it says determine the number of solutions. I would say no solution. Okay, number 4, I'm going to do the same thing. I'm going to get y by itself. So on the first one, I'm going to subtract the 5x over, divide by -6. So y equals 5 6x minus 7/3. If I get y by itself here, I need to subtract x, divide by 3. So y equals -1/3 x plus 5. So in this case, look at the slopes. They're different. Different slopes is this one right here, independent. So I'm going to say independent, consistent. Okay, and how many solutions? There would be one solution. And number 5, this one already has y by itself, and I'm going to rewrite it as 1/2 x plus 5. This one I need to get y by itself. Oops. So I'm going to add over the 10. X plus 10 equals 2y. Divide by 2. So y equals 1/2 x plus 5. They're the exact same line. So that's this one here. Dependent, consistent, and there's, infinite solutions. All right, moving on. Gosh, my numbering is off. 3, 4, oh, that's not. Number 6. Use substitution to determine, now this is confusing to some of you, use substitution. We just want to determine if the ordered pair is a solution or not. Okay, all we're going to do here is plug it in. So this is my x and y. So I have 8 equals -2 times -4 8 equals 8. That one works. Okay, and then I'm going to plug it into the second one. 3 times negative 4 plus 8. That becomes negative 12 plus 8. Negative 4 equals negative 4. Check. So this is a solution. Number 7. Oh, a little bit different here. We've got inequalities. Same thing though. We're going to still plug it in. So I have x and y. 3 is less than 11 minus 8. Is 3 less than 3? No, it's not. If it said the equal sign, that would be okay. But in this case, 3 is not less than 3. Let's plug the other one in just so you can see what it looks like. 11 plus 4 times 3 greater than or equal to negative 2. So that becomes 11 plus 12, which would be 23 is greater than or equal to 2. So that one does work because 23 is greater than negative 2. This one doesn't work though, so this is not a solution. Number 8, solve by graphing. Okay, lots of things here. Solve the system by graphing means you're going to give me the solution. Then it says state the solution and classify the system. So we need to get y by itself first. So I'm going to subtract x over, divide everything by 2. So y equals negative 1/2 x minus 1. And let's go ahead and graph that. And on your test, I want you to box this in so I can see what that line is. Negative 1, and I'm going to go down 1 over 2. Okay, so there's the first line. Okay, the second line, I'm going to subtract the x over, divide by 4, so y equals negative 1/4 x. Sorry about that. So there's my line. So my y-intercept is 0 because there's nothing here. So I'm going to start at 0, 0. And I'm going to go down 1 over 1, 2, 3, 4. Down 1, 1, 2, 3, 4. And I'll go up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4, like that. Okay, so I'm going to look for your equations. I'm going to look for, did you graph them correctly? And then, so here's the solution. So you tell me the solution would be negative 1, sorry, let me get that right, negative 4, 1. There is one solution, which means the system is independent, consistent. Okay, number 9, solve by graphing. So again, graphing, but inequalities. So on this one, let's get y by itself. I'm gonna switch that. So I just flipped the two sides because I want the y on the left. Add 6 over. So here's one line. I want to graph that. 1, 2, 3, 4, 5, 6. And I can't go up 7. I'll go down 1, 2, 3, 4, 5, 6, 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. And it's a dashed line. Okay, it's greater than, so I go to my line and I'm going to jump up. So I shade here. I'll do it this way. Okay, and now I want to check the other line. It's already in y equals mx plus b for me. So I'm going to start at negative 2, go down 1, 2, 3, 4, 5, and right 1 because it's a negative slope. Up 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5, and left. That one has the equal sign, so it's a solid line. And it's less than, so I jump down. So I would shade all of this. And here's my double shaded area. Okay, let's do another one, number 10. The first one's done for us. So I'll start at positive 4. 1, 2, 3, 4. Up 2 over 1. And that's a solid line. It's a greater than, so I jump up. So I'm going to shade above the line. The second one, let's get y by itself. So I'm going to subtract 2x over, divide by the negative, which means I have to flip the sign. So it becomes less than or equal to 2x minus 5. 1, 2, 3, 4, 5. I'm going to go up 2 over 1. and that's also a solid line. It has a less than, so I jump down, so I shade here. Now my shading areas didn't cross, so in this case there's no solution. And they never would cross because these are parallel lines. Number 11, use substitution to solve the system. Okay, substitution. We have a variable by itself already here, so I substitute this whole thing into the y in this equation. So 2x plus 4, and then for the y I put x plus 3 equals 24. So 2x plus 4x plus 12 equals 24. 6x plus 12 equals 24. Subtract 12 over, I get 12, and divide by 6. X equals 2. And then to find the y, I'll go back to that first equation. Y equals 5. Remember, we write our answer as a coordinate point, 2 comma, oh, I wrote 3. 2 comma 5. Okay, number 12, I need to get a variable by itself. So I'm going to take this first equation, and I'm just going to add the x over. So y equals x plus 5. I take x plus 5 and I put it into this y right here. So 2x plus 3 times x plus 5 equals 19. Distribute the 3. So combine like terms, 5x plus 15 equals 19. Subtract over the 15 and I get 4. Divide by 4 and I get 4/5. Okay, so to solve for y, I plug that into this equation right here. I get 4/5 plus 5, and I'm going to put that in my calculator. So 4/5 plus 5. I got 29 over 5. Okay, now before I go on 12, I want to come back to this one because I should have checked my answer here. So I'm going to plug in the x, 2 plus 3, and I got y, 5. I'm going to check this one. 2 times 2 plus 4 times 5 equals 24. Okay, so that works. So you should check your answers on your test. Now this one, it looks weird, so let's check it. I got 4/5 and 29/5. Okay, so I'm going to check that. So I'm going to do the y. The y is 29 over 5. I'm going to subtract the x. I'm doing this one right here. Subtract the x, 4/5, and that equals 5. Okay, so that one worked. Let's check the second one. 2 times the x plus 3 times the y, and that one works. Okay, so on your test, make sure you plug back in your answers. Even though I got a weird answer here, I put it back in and it works. Okay, so that ensures that you got this correct. Okay, number 13, use elimination to solve the system of equations. Let's see, I see both of these have the 4 already. I'm going to multiply this equation by a -1. So that becomes negative 5x plus 4y equals 0. And this one, the second equation stays the same, 8x minus 4y equals 12. So that's going to be 3x equals 12, divide by 3, x equals 4. So then I'm going to plug it back into the first equation. Put 4 in, which would be 20. I'm going to subtract over the 20 and divide by the -4, so I get 5. So I got 4 comma 5. Before I move on, let me check that. So I put into the first equation my 4 and my 5, I got 0. And then the second equation, and I got 12. So that works. Okay, number 14. Let's see, I'm going to get rid of the x's. So I'm going to multiply this equation by a -2 to make this a 4 and this a -4. So I have 4x plus 2y equals 12, and then multiply the -2. So -4x minus 12y equals 8. So the x's cancel. I get -10y equals 20. Divide by -10, y equals -2. And then I'll plug that back into the first equation. So that's 4x minus 4 equals 12. Add over the 4 is 16. And divide by 4, and I got 4. So my answer, 4, negative 2. So let's plug that in and make sure that it works. 4 times 4 plus 2 times negative 2 is 12. And 2 times 4 plus 6 times negative 2 equals negative 4. Perfect. So that works. Okay, number 15, solve by elimination. So here I see I have an x and a y. So I'm going to label these. I'm going to take b and c and I'm going to eliminate z. So I have equation b and I have equation c. So if I want to eliminate z, I've got a negative 4, this one needs to be a 4. So I'm going to multiply this whole equation by a 2. So I get negative 2x plus 6y plus 4z equals negative 8. And underneath that, negative x plus y minus 4z equals 10. So the z's are gone. I get negative 3x plus 7y equals 2. Okay, so I'm going to take my a equation and this equation and put those together. So I have x plus 2y equals negative 1. And I have negative 3x plus 7y equals 2. Okay, I want to eliminate either the x or the y here. It doesn't matter. I'm going to go for the x, so I'm going to multiply this one by a 3. And I'll rewrite it right here. So 3x plus 6y equals negative 3. Negative 3x plus 7y equals 2. The x's cancel. I get 13y equals negative 1. Divide by 13. Yikes. Negative 1 over 13. Okay, once you get this, you kind of work your way backwards. So I'm going to go back up to one of my star equations. So I'm going to put this into my a equation, this one. Yikes, this is ugly. So this becomes x minus 2 over 13 equals negative 1. If I want to solve for x, I need to add over 2 over 13. So in my calculator, I have negative 1 plus 2 over 13. And I get negative 11 over 13. Okay, now I need to solve for z. So, so long. Let's see. Negative, I'm going to go into the b equation. So I have negative x, which means I need to be careful with that negative, plus 3 times y plus 2z equals negative 4. So I'm going to first put this in my calculator. So I have negative 11 over 13 plus 3 times negative 1 over 13. So that equals 8 over 13 plus 2z equals negative 4. So I'm going to subtract 8 over 13. So negative 4 minus 8 over 13. Oh my gosh. Negative 60 over 13. And I need to divide that by 2. So I'm just going to say divide by 2. Okay, so let's see if this works. That is a horrible answer. Okay, so let me write my final answer right here, what I have. Negative 11 over 13 is the x. Negative 1 over 13 is the y. Negative 30 over 13 is the z. Now, we have to check it in all three of these. So, the first one, the x, negative 11 over 13 plus 2 times the y, negative 1 over 13, equals negative 1. So that works. Let's go to the second one. I have negative x, which is a negative 11 over 13, plus 3 times the y, which is negative 1 over 13, plus 2 times the z, which is negative 30 over 13. I hope this works because this is ugly and I am sorry about that. Negative 4, that one worked. Now we have to check all three because sometimes the third one doesn't work. So negative x, which is a negative 11 over 13, plus the y, negative 1 over 13, minus 4 times negative 30 over 13. Whew, and I got 10. Okay, so that does work. It's just really, really ugly. Okay, substitution. Now this one a little bit easier. X equals 2, so I'm going to put 2 right in here. 2 plus y equals negative 8. Subtract the 2. Y equals negative 10. And now I can put that into this third equation. So 5 times 2 minus 2 times negative 10 plus 3z equals 27. So this becomes 30. Subtract over the 30. 3z equals negative 3. Z equals negative 1. So I have 2, negative 10, negative 1. Okay, let's double check that. So I don't have to check the first one. The second one is just x plus y. So 2 plus negative 10 is negative 8. And then the third one, 5 times 2 minus 2 times negative 10 plus 3 times negative 1 equals 27. So that works. Okay, last page, word problems. Okay, so on the test tomorrow, there's 4 word problems. They're 8 points each. So there's going to be, it's 4 points to set up the equations. We want to see that. And then, of course, 4 points to solve it and get the correct answer. All right, so Mrs. Stout, apparently I make baseballs and footballs. I charge $5 a baseball, $12 for a football. 1 month, she sold a total of 18 baseballs and footballs and earned $160. Okay, so let's start with our totals. Our totals, we have 18 total baseballs and footballs. So I'll just write 18 total balls. And I have $160. Okay, so there's my 2 totals. And then what are we comparing? We're comparing baseballs Okay, so I'm going to use B for the number of baseballs, and I'll use F for the number of footballs. Okay, so for the total number of balls, I have baseballs plus footballs equals 18. Since this is money, this is where my money goes. So I have still baseballs plus footballs, but in front, we want to put how much a baseball is, which is $5, and in front of the footballs, I want to put $12. So this is money plus money equals money. It should match up. If you put $5 here and $12 here, and then you have 18 baseballs and footballs here, something's not right. Okay, so there's my 2 equations. Now let's solve them. So you can solve by substitution or elimination here, whichever method you prefer. I'm going to do elimination, so I'm going to multiply this first equation by -5. Let's see, 18 times -5, -90. So the b's cancel. I get 7f equals 70. Divide by 7. So I get 10 footballs. And then I'm going to plug it back in over here. If I have the number of baseballs plus footballs, which is 10, equals 18. Subtract the 10, and I get 8 baseballs and 10 footballs. Now, before you move on, check that. Make sure that it works in your equation. So let's check it over here. We have 8 baseballs plus 10 footballs. That definitely equals 18. Well, let's check this. $5 times 8 baseballs plus $12 times 10 footballs is $160. So that works. Okay, number 18. Adam has a coin collection. He has nickels and dimes. He has 23 coins, and the value of the coins is $1.55. Write the system of equations to find how many nickels he has. Okay, so that's kind of a repeated question. Let's take that off. All right, so again, our totals. He has 23 coins, and he has $1.55. So he's doing nickels and dimes. So let's use N for the number of nickels and D for the number of dimes. Okay, so for our total number of coins, we just have nickels plus dimes. For our money, I still have nickels plus dimes, but same thing as the baseball football one. I need to know how much is a nickel and how much is a dime. So I have to put in 0.05, not a 5, because I'm doing 5 cents, and then for the dime, 0.10. Okay, there's my two equations. Okay, so here's my equations. You can solve by substitution or elimination. I'll do substitution on this one. That way you can see what it looks like if you like that method better. So I'm going to solve for n by subtracting the d over. I'm going to put this into this n right here. So 0.05 times 23 minus d plus 0.10d. Just be really careful of your decimals here. So I'm going to multiply out this 0.05. So 1.15 minus 0.05d. Okay, I'm going to combine like terms here. So 1.15 plus 0.05d equals 1.55. Subtract, and I'm out of space, so I'm going to come over here. 0.05d equals 0.4. So I get d equals 8. Okay, so I have 8 dimes. So come back over, all the way over here, move my paper over, right here. So if I have 8 dimes, I want to subtract over 8. 23 minus 8 is 15. So 15 nickels and 8 dimes. Now let's double check ourselves here. So 15 plus 8 is 23. And then let's check this one. 0.05 times 15 plus 0.10 times 8 is $1.55. So that works. Okay, number 19. You have an iTunes Music Pass. You have 2 ways of buying music. Option A, buy a monthly pass and pay 25 cents per song. Option B, pay $1 per song. So a monthly pass costs $25. Okay, option A, I can buy the monthly pass, $25, and pay 25 cents per song. I'll use S. Option B, I just pay $1 per song. After how many song purchases will the total cost of the 2 options be the same? So when it's the same, I set them equal to each other, and I want to solve for S. So I'm going to subtract. So 25 equals 0.75S. After how many song purchases? I don't think that works. I got S equals 33.3. So it's not exact. I might try to fix that and see if I can get it right. Okay, but when it talks about option A, option B, and when will they be the same, you set them equal to each other. Okay, I might try to fix that one, see if I can get it to be the same number. Okay, last one, number 20. Mark earns $7.50 an hour mowing lawns and $12.50 cleaning pools. Last week he earned $270 for 26 hours. How many hours did he spend mowing lawns and cleaning pools? So let's do our totals. We have $270 and we have 26 hours. Okay, so what's he doing? He's mowing lawns. So I'm going to do M for number of hours mowing. And I'm going to do C for number of hours cleaning. Okay. So this becomes M plus C, because this is just hours plus hours equals hours. And then here's where I put the money in. He gets $7.50 mowing, and he gets $12.50 cleaning. Okay, so there's your 2 equations. So you can solve by substitution or elimination. I'm going to solve by elimination. So I'm going to multiply this equation by negative 750. And I'm out of space. Let me get some space here. Okay, so this becomes, the top equation stays the same. The bottom equation becomes negative 750m minus 750c equals 26 times negative 195. The m's cancel. So 1250 minus 750. 5c equals 75. Divide by 5. C equals 15. Okay, so go back to my 26 hours. M plus 15 equals 26. Subtract 15. Oopsies. So M equals 11. So he spent, I'm just going to put it right here, 11 hours mowing and 15 hours cleaning pools. And let's just double check that real quick. 750 times 11 plus 1250 times 15, $270. Perfect.